Everyone, my name is Mr. Segun and I'm a mathematics tutor. So today we'll be looking at a very important topic in mathematics and a very interesting topic also, which is sequence and series. Sequence and series. So this topic actually is a very broad topic, alright? But we're just going to we're just going to take this topic in, alright? We're not going to go into too deep because of our time. So let's just look at what this topic is all about. So please stick with me to the end of the video so you can get a better understanding. Now, I will start by giving us a definition of what these two words are. So we have two words here. We have sequence and we have what? Series. Please permit me, I don't really write definitions, right? I just go straight down into questions and calculations. But I will do an overview or give us an overview of what sequence and series is all about. Now let's start with sequence. Now when we say sequence, a sequence simply is the progression of numbers. Alright? So take note of the word progression of numbers. Alright? Progression of numbers. So basically that is what a sequence is. So you have numbers, alright, progressing. So that is basically what constitutes a sequence. Now, in this case, progression in this context rather, might not really be in an increase. So you might have numbers like 2, 4, 6, 8, 10. This is an example of a sequence, right? This is an arithmetic progression actually. We'll get to that later. You can also have -2. Now, this is also a kind of sequence. Now, so what I'm trying to paint in, what I want to try to get, what I want to let us know is that in this case, this constant context of progression doesn't actually mean increase, alright? Yet, it can mean increase and it can also be in form of a decrease, alright? So please take note, sequence is the progression of numbers, whether in form of a decrease or in form of what? An increase. Alright, so that is basically what a sequence is. And we have lots and lots of them. We have harmonic sequence, we have Fibonacci sequence, we have arithmetic progression, we have geometric progression, we have so many types of sequence, right? But for this course or for this topic, we're just going to be looking at two, alright, which is the arithmetic progression and the geometric progression. So now that I've given us a background of what sequence is, so let's quickly go into the second word, which is what? Series. What is a series? Now, a series is not far-fetched actually. They are quite related, right? Now, the difference between a sequence and a series is series are also sequence, all right? But the difference is, now looking at this, in a sequence, sequences are separated by commas. That's separated by what? Commas. But series, they are not separated by commas. They are separated by the plus sign. So that's the difference. So I'm going to wipe this off and put plus. So that is simply the difference between a series and a sequence. So a series is separated by the plus sign, while a sequence is separated by the comma sign. It is as simple as that. Alright, now moving on, let's go back to sequence. Now, like I said, there are different types of sequence, right? We have our harmonic sequence, Fibonacci sequence, and so on and so forth. But we're going to look at just two. Now, the first one I want us to really look at, alright, is what we call the arithmetic progression. Arithmetic progression. In short, in mathematics we call it AP. Alright? It is often called AP by students and teachers. Now, let me quickly explain what this is. We have different kinds of sequence, right? Now we have arithmetic. Now, what I want to let us know is I want to give us a better understanding of what arithmetic progression is, or what makes arithmetic progression different from every other type of sequence. So please pay attention and listen now. Now, an arithmetic progression is a sequence that increases, alright, or that progresses, as the name implies, by a common difference. That is the basic definition of what arithmetic progression is. So let me recap that again. I said arithmetic progression is the progression of numbers by a common difference. So the key word you have to take out of that definition is common difference. Common difference. So that simply tells you if it doesn't have a common difference, it is not arithmetic. It is not what? Arithmetic. So please take note of that. It is not arithmetic. So please, an arithmetic progression doesn't just constitute numbers. Now these numbers are arranged in a way that arranged in such a way that their increase or decrease is by a common difference. So let me give an example so you can get it better. You can have a sequence like 1. Now, in this particular sequence, right, this is an arithmetic progression. How do I know this is an arithmetic progression? Because it has a common difference. Now, a common difference is represented by the letter D. Now, let me explain what I mean by common difference. If you add 2 to 1, you get 3. If you add 2 to 3, you get 5. Add 2 to 5, you get 7. Add 2 to 7, you get 9. Now, you notice that there is a particular number you keep adding to get the next step. That number is what we call common difference. So that is basically the definition of common difference. So the reason why we call it common, because it is constant in every step. If it is not constant in every step, then that sequence is not arithmetic. So please, that's what we mean by that. Another example you can have is you can have 3, 7, 11, 18, 19. This is another example of a what? An arithmetic progression. Why? If you add 4 to 3, you get 7. Add 4 to 7, you get 11. Add 4 to 11, you get 15. Add 4 to 15, you get. So you see that you keep adding a particular number to get the next step, right? So and that number there is the common difference. So we say common difference here is 2. The common difference here is 4. And there's a formula we use to find the common difference. And the formula is T2 minus T1. Whenever you see this word, this T2, T1, T2 means second term, T1 means first term. So this is the general formula we all use. And you can also, this is second term minus first term. You can also use third term minus second term. It's still the same thing. Or you say fourth term minus third term. So basically, just take the term and subtract it by the previous term. Alright, that is how you get the common difference. So now, like I said, so this is what makes a sequence arithmetic, please. That is what makes a sequence arithmetic. Now let me give you an example of a sequence that is not arithmetic so you can get the idea, right? So let's say for instance, okay. Now, if you should look at this sequence, right? What is the difference between this sequence and this? If you should look closely, as a mathematician, these are things you have to have this how to know how to observe very well, right? Especially when it comes to data, right? So please. Now, if you look closely, right, you will notice that this one is arithmetic, this is not. Why do I say that? Looking at this now, if you add 4 to 1, you get 3. But if you add 2 to 1, sorry, you get 3. But if you add 2 to 3, you're not going to get 6. So that means there is something wrong. So this is what is happening. If you add 2 to 1, you get 3. If you add 3 to 3, you get 6. If you add 4 to 6, you get 10. If you add 5 to 10, so you notice something here. Here, you added 2. Here we added 3. Here we added 4. Here we added what? So you can see that the common difference is changing. So in this case, it is not arithmetic. So the reason why what makes a sequence arithmetic is that the difference is constant. Constant in the sense that it is the same thing here, the same thing here, here and here. So that's what we have here. Here it was 2, 2, 2, 2 all the way. Here 4, 4, 4, 4. Did you get the idea now? So that is just it. So what makes it arithmetic is because it is constant, the same thing all through. But over here, that's not the case. So this is not, so you can say not an arithmetic progression. It is not an, although this is a sequence, but not an arithmetic sequence. It can be another type of sequence. Are you with me now? But not arithmetic. So this simply says that every sequence, every progression is a sequence, right? Or every sequence is not arithmetic, but all arithmetic progression are sequences, but not all sequences are arithmetic progression. So you can put it that way. All arithmetic progression are sequences, but not all sequences are arithmetic progression. If you get the idea of what I'm saying. So that's just it. So let's go straight up into some examples. Or before examples, let's see some other things we need to know about arithmetic progression. Now that we've established that, we want to look at something else. Now this is called nth term of an arithmetic progression. Nth term of an arithmetic. I will explain what this is. Now, nth term of an arithmetic progression is a formula, and the formula is used. You ask me, what do we use the formula for? Good. The formula is used to find the value of a term in a given arithmetic sequence. So let me recap again. Nth term of an arithmetic progression is a formula we use to find the value of a term in an arithmetic progression. So, for instance, if I have, let's take the previous sequence we used earlier, right? 1, 3, 5, 7, 9, so on and so forth. So meanwhile, please take note. If you see 3 dots, that tells you that the sequence still continues, right? It doesn't end. Now, let's say for instance, we're not given this guy. And let's say this was x. Alright? Now, what nth term of an arithmetic progression, what it does for us is that it will tell us the value of this guy. Alright? So it is a formula that helps us to display or shows us the value of a term in a sequence when it is not given. So in this case now, x here is not given, we don't know it. So nth term is a formula that we use to find the value of that term, right? So that's basically what nth term of an arithmetic progression is. So let me show you the formula. And it is now time will not really permit me to show you how it was derived because we have some areas to cover in this video. But this is basically the formula for nth term of an arithmetic progression. It is Tn equals a plus n minus 1b. I'll tell us what this letter stands for. A stands for first term. This is nth term. Most textbooks use un, right? Yes, actually, but some textbooks use Tn. N stands for number of terms. D stands for common difference. D stands for common difference. So we said Tn is n term, A first term, N number of terms, D common difference. So that means there is a formula we can use to find any term in the sequence. First term, second term, third term, fourth term. So let's assume we are given a sequence and then they ask us what is the value of. So we have T1, T2, T3, T4, T5, T6, and so on and so forth, right? T1 is also called A, which is first term. T1 is also called A. So that means if I were asked to find the fifth term, for instance, alright? Fifth term in this case is, you are looking for the fifth term now, right? So I'm just going to use this formula and say T, since the number of terms we are looking for, fifth, that's the number of terms is 5, right? So let's assume now, or take an example. For instance, I'm looking for the fifth term. So the number of terms I'm looking for is 5. So n is 5. So I'm going to say T5, which is the fifth term, is equal to, what will be the formula if I want to find the fifth term? Fifth term will be A plus, into brackets, remember n 5, right? Then minus 1, and then we have what? D. So you have the fifth term, A plus 5 minus 1, that's 4. So this is the formula I'm going to use to find fifth term. So you can do this for every other term also. 100th term, 20th term, 90th term, whatever term it will be. So let's take one more example. Let's say I'm looking for the 19th term. So in this case, n will be what? 19. Let's say for instance, I'm looking for the 19th term. So I'll say T19 is equal to A plus, in this case now, n is now what? 19 minus 1 and then D. So T19 is equal to A plus, this is what? 18. So this is the formula I'm going to use to find the 19th term. So that is how it works. So let's take an example and apply this formula there. So we have a question here. We will start. Since we have a good background of what nth term of a sequence of an arithmetic progression is, we want to apply that formula here. So it says, given the arithmetic progression 9, 12, 15, 18. So you have 3 dots here. That tells you that the sequence still continues. It said find its A, 8, B, 99, and C, nth term. So we are looking for the 8th term, 99th term, and the nth term. So let's start with the first question. A. Now, remember, what's the formula for nth term of a sequence? Remember I told us we use it to find the value of a term in a sequence, right? So Tn is equal to A plus 9 and n rather minus 1 D. I told us where Tn stands for nth term, A stands for first term, n stands for number of terms, D stands for common difference. Now, when we're looking for a particular term here, we're looking for what? 8th term. Good. So that means our n is what? The number of terms we're looking for is 8. Remember, right? Exactly. So what will be the formula for finding the 8th term? So this is what we'll do. Say T8, anywhere you see n, just put in 8. That's all. Right? So that's A plus then 8 and then D. So you have 8th term is equal to A plus 8 minus 1, 7. So this is the formula I would use to find the 8th term. Okay? So let's go. Now remember I told us A here is what? The first term. A stands for first term. T1, A. So what's the first term here? The first term here is A. So let's take out our parameters. We have A is 9. Now also we need to find the common difference. Common difference simply means what numbers or what values are they increasing or decreasing by. Alright? If you look at this, actually you don't even need to use the formula for it. Looking at this, we know that they are increasing by 3. So the common difference here is 3. You might ask me, how did I get it? It's very simple. Remember we said the formula is T2 minus T1. So what's T2? T2 is second term, which is 12, minus first term, which is T1, which is also 8. Right? Is what? 9. So what's 12 minus 9? 3. So common difference is 3. So now that we know that, let's put it there. A is 9 plus 7 into bracket. What is D, which is what? 3. If you continue from here, we have that the 8th term is equal to what? 9 plus 7 times 3, that gives us 21. So 9 plus 21, that's what? 30. So that means the value of the 8th term. So if you continue, first term, second term, third term, fourth term, fifth term, seventh term, 8th term, you will notice that the 8th position or the 8th value is 30. Alright? So that's that. About that. So let's quickly move on to the next one. B. For B, our n in this case is a what?
our n is 99. Good. So the same thing, T99 is equal to A plus 99 minus 1D. T99 is equal to A 98D, right? So this is the formula I'm going to use to find the 99 term. So T99 is, my A is 9 plus 98, my common difference is still the same thing, 3. So 9 plus 98 times 3, that should give us 9 times 3 is 27, that's 294. So this is 294. Okay, so add them up. What do we have? 294 plus 9, that's 303. So therefore T99 is 303. So that is the value of T99. And then quickly the last one, right? Nth term. Nth term. Nth term, now this, whenever you're asked to find nth term, this is it. Nth term simply is give us a formula specific to this arithmetic sequence. Now, nth term of an arithmetic progression is a general formula, right? That is applicable to all arithmetic progression. Now, but whenever you're asked to find the nth term of a sequence, meaning the formula must be specific to that sequence. Alright? So this is how you do it. Now, in this case, your n is still your n. Alright? Because it doesn't have a value of n. So this is what we do. We use that formula. Tn is equal to a plus n minus 1d. So the only thing you are going to evaluate here is the common difference and the first term. That's the only thing you are doing, right? So let's go. Tn is equal to a is what? 9, n unknown, so just put n, and then d is a. So Tn is equal to 9 plus 1. Now open up the brackets, right? 3 times n, that will be 3n. 3 times minus 1, that will be minus 3. So Tn is equal to 9 minus 3 plus 3n. Then Tn is equal to, what's 9 minus 3? 6. 9 minus 3 is 6. And then you have plus 3n. So this formula is the nth term of this sequence. So meaning nth term of a sequence, meaning is a formula that is specific or only applicable to that particular sequence. So the difference between this one and nth term of an arithmetic progression is that nth term of an arithmetic progression is a formula that is applicable to every arithmetic sequence. Now, but for this one, nth term of this sequence is a formula that is only applicable to just this sequence. Alright? So that is how to use nth term to the formula to solve for the values of a term in a sequence. So that will be all for today. So in our next class, hopefully I might shed more light because there's still a lot of areas to cover under arithmetic progression. Alright? We're going to look at some of AP, so on, how to, there's some questions you write, there's some other complex questions under this. So thanks for watching and see you in the next class.